Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this chapter 10, we will have a nodal analysis. The circuit will get involved with a resistor, inductor, and also capacitor. So we need all impedance for these elements. Okay. So what is the steps we're going to take for chapter 10? Basically, first we're going to have to solve this nodal analysis. We need the phasor form. Phasor form. If you have sources in sine wave, form, you can convert it to a cosine. So let's say you have a negative sign, then if you want to convert it to cosine, then you can plus 90 degree. If you have a sine, then you can minus 90 degree to convert it to cosine. Second, use the impedance equation. If you have impedance of R, then this is R, and impedance of L, you have a J omega L, and impedance of C, you have a minus J over omega C. And step number 3, figure out the reference point. Usually this is at the bottom of the circuit, and we put reference point at the most the node with the most branches. Okay, usually at the bottom. And then third, also we need to figure out all the nodes. You need to name the nodes. If you can give the value of the nodes, then you state the value of each node. Let's say the value is 10 volt, then give it a 10 volt. If this is an unknown value, then you give some V1 or Vs. Depends on what you want to have. Right, number 4, give the current direction of each elements. So if you have, in my class, usually horizontal, we have from the left to the right current flowing, and vertical from up to down. And it is okay to assign from right to left or left to right or up to down, down to up, no problem. But you need to follow the passive sign convention of each element. If you have a passive element, what is a passive element? Some element like resistor, inductor, or capacitor is a passive element. Then when you have a passive element, the current entering a passive element should have a positive terminals, and the leaving current should have a negative terminals. Steps number 5 is that you need to figure out the supernode. How to figure out supernode for nodal analysis? This is by looking at the independent sources, usually a voltage source, or dependent sources, also a voltage source, and this voltage source should be in between two nodes, which is the unknown nodes, like maybe V1, V2, Vx, or Vy. Depends on the nodes you have. As long as this is the unknown nodes, then you can take this as a supernode. And if you have something in parallel with this voltage source, then you need to include as one supernode. Okay. And what will you do? If you have a supernode, you need to have two equations. One is the KCL at the node, meaning to say, if you have a border for supernode, then current entering this border should be equal to current leaving the border of this supernode. If you have a KVL, then how to do the KVL for supernode? the higher in polarity, which is V1, should be minus with the lower in polarity, which is equal to V2, equal to the value of the voltage source. Maybe here the voltage source is equal to 10 volt. Then this is equal to 10. Okay, so this is a KVL. Alright. Okay, then the last steps is to build equation for all unknown nodes. All unknown nodes. So what is that equation? This is a KCL. Okay, KCL, equation of the unknown nodes. Okay, I think that's all for nodal analysis for chapter 10. We will continue in our next video with the example for nodal analysis of chapter 10. Thank you.